Ladies and gentlemen, I want us to look at stationary points in the topic of differentiation. Now, I want us to take note of this in stationary points. That stationary points are points where the function neither decreases nor increases. That stationary points, they are points where the function neither decreases nor increases. Secondly, we can say that the gradient at a stationary point is 0. We can say that that is dy over dx equals to 0. Thirdly, we can say that a stationary point can be a maximum, a minimum, or a point of inflection. That a stationary point can be a maximum, a minimum, or a point of inflection. Fourthly, we can say that at a maximum point, the gradient changes from positive to 0 to negative. We can sketch this one, that the gradient changes from positive, that is from positive to 0, then to. Fifthly, we can say that at a minimum point, the gradient changes from negative to 0 to positive. We can say that at a minimum point, the gradient changes from negative to 0 to positive. That is, we can sketch this, we can sketch that it changes from negative to 0, then to positive. So the graph changes, that not the graph, but that is the gradient changes from negative to 0, that is to 0, then to positive. So this is the nature of a minimum point. This is the nature of a minimum point. At a point of inflection, the gradient does not change the sign. That at a point of inflection, the gradient does not change the sign. We can say that it can be, that is, it can be negative, positive, not positive but 0, that is negative, 0, then negative. So it is, that is the gradient is negative, then at this point it becomes 0, then at this point it becomes negative again. So it has not changed the sign. Or it can be also, that is positive, 0, then positive. That is, it is positive at this point, then at this point it is 0, then at this point it is positive. So the gradient at the point of inflection does not change the sign. The gradient at the point of inflection does not change the sign. It can be from negative, it changes to 0, then it changes to negative. Or it can be from positive to 0 to positive. Now, I want also to say that stationary points are also called turning points. Stationary points are also called turning points. They are also called turning points. That is, turning points. Stationary points are also called turning points. Now, I want us to look at this question and try to evaluate or try to solve this question. The question is, find and classify the stationary points of the curve y equals to x cubed minus 3x plus 3. Now, let us have a look at the solution. Let us have a look at the solution. This is the equation of the curve. Now, we need to find the gradient function first. That is dy over dx will be, that is dy over dx will be, if we differentiate this polynomial, we shall have, this is the first term, that is x cubed. If we differentiate x cubed, we shall have 3 x raised to 3, but we less the power by 1. And if we differentiate 3x, we shall have, that is minus 1, because the power of x is 1, then into 3x raised to 1, then we less the power by 1. Then close the bracket. If we differentiate positive 3, we get 0, because positive 3 is a constant. Therefore, we have our dy over dx as, that is 3x, 3 minus 1 is 2, minus, this is 1 into 3x raised to 0. Then we shall have, that is 3x raised to 2 minus, this is 1 into 3x raised to 0 is just 3 times 1, which is 3. Then we shall have, this one will be 3x squared minus 3. That is the gradient function that we have. Since this is the gradient function that we have, we can say that at stationary points, dy over dx is 0. At stationary points, dy over, that is dy over dx equals to 0. Therefore, we can say that 3x squared minus 3 equals to 0. Now, we can divide by 3 here, and also here by 3, and also here by 3. That is, we divide by 3 throughout. We shall have, that is by 3, 1, by 3, 1, by 3, 1, by 3, 1. Then 0 divided by 3 is 0. Therefore, we shall have, this one will be x squared minus, this implies that x squared minus 1 equals to 0. Now, we can expand this, that is x squared minus 1 equals to 0, so that we shall have, that is x minus 1 and also x plus 1 equals to 0. So this one is just the expansion of this expression. Now, this means that x minus 1 can be 0, or x plus 1 can be 0. Now, in this case, we shall have our x as, if we take 1 to the other side, it will be positive 1. Or, in this case, x plus 1 equals to 0. If we take x, that is, if we take 1 to the other side, because it is positive at this point, it will be negative, the other side. Now, the value of x is either 1 or negative 1. Now, we need to obtain the stationary points. We need to obtain the stationary points. That is, when x equals to 1, what will be our y? We substitute the value of x, that is with 1, on our original equation of the curve. Now, we shall have our y as, instead of x, we shall have 1, so it will be 1 cubed, then minus 3 into 1, then plus 3. Then in this case, we shall have y equals to 1 cubed is 1, then negative 3 times 1 is negative 3, then plus 3, it will be 1 minus 3 plus 3. Negative 3 plus 3 is 0, then plus 1 is 0. So we shall have, that is 1. The value of y will be 1. Now, after obtaining the value of y, we shall have our first stationary point as, that is x is 1, and then y is 1. Therefore, the first stationary point is 1, 1. Let us proceed to look for the second stationary point. That is, when x is negative 1, what is our y? We shall substitute in our original equation. We shall substitute our value of x with -1 in our original equation of the curve. Therefore, we shall have our y as, that is bracket -1 cubed, then minus 3 into -1, then plus 3. And in this case, we shall have, that is y equals to -1 cubed is -1. -3 times -1, it will be positive 3, then plus 3. In this case, we shall have our y as -1 plus 3 is positive 2, plus 3, it will be 5. It will be 5. And therefore, the value of y is 5 when x is -1. Therefore, the second stationary point will be -1, 5. It will be -1, 5. Now, these are the stationary points that we have. And our question was, we find and classify the stationary points of this curve. Now, we have already found the stationary points. Now, let us classify the stationary points. Classifying the stationary points is stating whether maybe point 1 is a minimum, a maximum, or a point of inflection. Or point 2 is also maybe a minimum, a maximum, or a point of inflection. Now, let us start with the first point, that is point 1, which has the coordinates as 1, 1. To check the stationary points, we can say that to check the stationary points, comma, find, that is the sign of the gradient, find the sign of the gradient, that is just find the sign of the gradient just before and after x equals to 1. That is, to check the stationary points, we need to find the sign of the gradient just before and after x equals to 1, because in our first point, we have 1, 1. The value of x is 1 because the coordinates are always in the form of x, y. Therefore, our x is 1 and our y is 1. Therefore, to check the stationary point, find the sign of the gradient just before and after x equals to 1. So, we need to find the sign, that is the sign of the gradient, just before this one and after this one. Now, we shall have this table in order to check, that is, the stationary points. We shall have this table in order for us to check the stationary point. In that, we shall have our 1 at the center. That is, we shall have this column, and this column. That is just before negative, that is just before 1. Just before 1, we shall have, that is 0. Just before 1, we shall have 0. And after 1, we shall have 2. After 1, we shall have 2. Those are whole numbers. And our dy over dx, when x is 1, is just 0. We can prove it. That is, since we have, that is the gradient function, then we can just say that we substitute x with 1. That is, if we substitute x with 1, we shall have, that is 3 into 1 then squared minus 3. That is what we have in our calculator. What do we obtain? What do we obtain? We obtain 0, as you can see. That 3 into x squared minus 3 is 0. Therefore, we shall have our dy over dx as 0 here. And if the value of x is 0, we also substitute 0 here. What is our dy over dx? If we substitute 0 there, then we can just have 3 into 0 squared minus 3, which is negative 3, which is negative 3. Therefore, we have negative 3 here. That is negative 3. Now, when x is 2, what is our dy over dx? We substitute, that is x, with this 2. And therefore, we shall have, that is 2. What do we have? We shall have positive 9. We shall have positive 9. That is, we shall have positive 9. Shall have positive 9. Now, the sign is that this is negative 3. Therefore, this is negative. Then this is 0. Then 9 is positive. Therefore, this is positive. This is positive. Now, in this case, this is negative, this is 0, and this is positive. Therefore, this is a minimum point. This is a minimum point. We can therefore say or conclude to say that this point is a minimum point. It is a minimum. That is a minimum point. This is a minimum point. That is our conclusion in this. That the point, the first point which has the coordinates as 1, 1 is a minimum point. Now let us check the second stationary point. The second stationary point is negative 1, 5. Now let us check for this. It is just, we can just use the same procedure to check whether it is a minimum, a maximum, or a point of inflection. Now, let us check the second point. That is, we shall have this, table, whereby it has 3 columns. We shall have negative 1, that is the value of x here, negative 1 at the center. Then just to the left, just before negative 1, we shall have negative 2. And after negative 1, we shall have 0. Now, we need to obtain dy over dx. Dy over dx when x is negative 1. Negative 1 is just 0 because if we substitute this x, because dy over dx is 3x squared minus 3. So if we substitute this negative 1, it is just 0. And we can prove it. We can prove that. We can, that is, press it in our calculator. We can press in our calculator. That is 3 into negative 1, then squared, then minus, that is negative 3. Negative 3. What do we obtain? It is, that is, it is, we have put another negative, no. It is, that is 3. That is 3. So what do we obtain? That is 3x squared minus 3. That is, we can even remove this from the bracket so that we just have it like this. This one is 0. 3 into negative 1, then we square it, then minus 3 is 0. Therefore, we shall have, that is our dy over dx when x is -1 as 0. Then, when x is -2, what is our dy over dx? We shall substitute it here also, so that we can have, that is -2. We can have 3 into -2 squared minus 3. We shall have it as +9. And therefore, this one can be, that is 9. This one is 9. Then when x is 0, what is our dy over dx? We shall just substitute it, so that we shall have 3 into 0 squared minus 3, and that is -3. That is -3. This one is -3. Now, since we have obtained dy over dx, we shall look at the sign. This is positive, so we shall write it as positive. That is positive. Then this is 0. We shall have it as 0. This is negative. This is negative. Therefore, the sketch is positive is like this, then 0 is like that, and then negative is like that. So this is the nature of the stationary point. That is the stationary point, which is -1 and 5. So looking at this, it is from positive, the sign of the gradient or the sign of dy over dx, it changes from positive to 0 to negative. That is positive to 0 to negative. And therefore, this is a maximum point. This is a maximum point. We shall conclude and say that this is a maximum point. This is a maximum point. That is, point 1 was a minimum. Point 1 was 1, 1. It was 1, 1. That was a minimum point. Now, our question was for us to find the stationary point, and classify the stationary points of the curve. So we have gotten the points. So we have point 1 as 1, 1, and point 2 as -1, 5. Then point 1 is a minimum point, and point 2 is a maximum point.